Have you ever wondered why some plastics are crystal clear while others seem to distort the light? All comes down to a single number, the refractive index. Today we are exploring how light travels through plastic materials like polycarbonate and PMMA, and why this property is a game changer in both medical devices and consumer optics. So, what is ASTM 542? ASTM 542 is the standard test method used to measure the index of refraction of transparent and translucent organic plastics. The refractive index detects how light bends as it passes through the material, which is critical for optical lenses, display screens, and quality control. The refractive index is calculated using the sine formula derived from Snell's law as the ratio of the sine of the angle of incidence, that is I, to the sine of angle of refraction, that is R. N equal to sine I by sine R. Here N is the refractive index, I is the angle of incident, and R is the angle of refraction. So what is refractive index? A refractive index is a measure of velocity of light through vacuum to the velocity of light through medium. What is the significance of refractive index? A refractive index is a fundamental property of matter which is useful for the control of purity and composition for simple identification purposes and for optical parts design. Refractive index values are very important to a design engineer involved in designing lenses for cameras, microscope, and other optical instruments. Then we will discuss test method. ASTM 542-00-2006 standard test method for index of refraction of transparent organic plastic. In specimen and conditioning, the test specimen shall be of size such that it will correctly fit on the face of the first half of the refractometer prisms. A specimen measuring 6.3 mm into 12.7 mm on one face is usually satisfactory. Specimen shall be conditioned at 23 plus or minus 2 degrees Celsius and 50 plus or minus 5% relative humidity. Which equipment is used for measuring refractive index, that is Away refractometer? An Away refractometer is a classic benchtop laboratory instrument used to measure the index of refraction, that is N, and sugar concentration breadths of liquids, plastics, and solid substances. It operates on the principle of the critical angle, requiring only 1 to 2 drops of a sample to provide a highly accurate reading. Then now we will discuss the procedures. Two procedures are normally used to measure the index of refraction of plastic materials. One is refractometric method and the other is microscopical method. First we will discuss refractometric method. The refractometric method is an analytical technique used to determine the composition, purity, and concentration of substances by measuring their refractive index, the degree to which light bends as it passes through the medium. It is widely used for quality control, checking for adulteration, and calculating solute concentration. Then the procedure is a source of diffused light is placed so that a good illumination is obtained along the plane of the surface of contact between a specimen and the refractometer prism. A small drop of a suitable contacting liquid is placed on the polished surface of the specimen. The specimen is placed in firm contact with the surface of the prism and with the polished edge of the specimen towards the source of light. Then the index of refraction is determined by moving the index arm of the refractometer so that the field seen through the eyepiece is half dark. The index arm is then adjusted in such a way that the dark light position of the field coincides at the intersection of the crosshair. The value of the refractive index directly recorded at this point. Now we will discuss microscopical method. Microscopical methods to determine the refractive index, that is RI, is generally rely on either measuring the apparent depth of a transparent medium using a calibrated focusing scope or observing the optical contrast of tiny particles immersed in reference liquids using the Nikon's microscopy U or science directed guides. Then this method is based on the well-known phenomenon that apparent depth of a transparent object is viewed through the thickness which is less than the true depth. Refractive index being the ratio of real depth to apparent depth. For measuring refractive index, a standard microscope having magnifying power of at least 200 diameters and a means of measuring the relative movement of the objective lens to the sample with an accuracy of 0.025 mm is required. A specimen of about 6.3 mm thickness having two parallel surfaces is placed on the measuring microscope table such that the polished surface is placed nearest to the objective. Care should be taken to ensure that the specimen is free from dirt, grease and scratches, which greatly influence the results. The reading in the longitudinal displacement of the lens tube noted to the nearest 0.025 mm or less. Without moving the specimen, the microscope is focused on the top surface of the specimen and again the reading of the displacement is noted. The difference between these two readings is the apparent thickness of the specimen. Then now we will discuss result. The value of refractive index is calculated by dividing the actual thickness of the specimen to the apparent thickness of the specimen. That is the index of refraction n equal to actual thickness of specimen divided by apparent thickness of specimen. And factors affecting wavelength of light. First factor is wavelength of light. Light has a smaller wavelength in a transparent material than in vacuum. Smaller the wavelength, higher the refractive index. Then temperature. The temperature of the experiment adversely affects the refractive index of the plastic materials. A linear decrease in refractive index is observed as the temperature increases, and as the transition is passed, the rate of decrease becomes greater. In short, a higher refractive index means more light bending and thinner lenses. I hope this cleared up how optical clarity works in plastics. If it did, hit that like button so I know to make more videos like this. Thanks for being part of the Plastic Farm Tech community. Keep studying and I will see you soon.